Hi guys, it's Miss Washington, and today we're gonna practice drawing atoms using 8-man, just like we learned yesterday. So today we're gonna do a full practice of 4 different elements. So what I want you to do is fold your paper in half, and then you're gonna fold it again in half, which will give you 4 different sections on your paper. You can use printer paper, you can use a notebook paper. It's totally up to you. Either way, we're gonna practice 8-man today. Okay guys, when drawing atoms, the first thing you wanna know is that protons are always equal to the atomic number. So if I have 14 protons, the atomic number will also be 14, which means that my element is silicon. If I have 6 protons, then my atomic number is 6. Which means that my element is carbon. If I have 3 protons, I can look for the number 3 on my periodic table, which will bring me to lithium. This number is always the same as the amount of protons. The second thing you need to know is that valence electrons equal reactivity. So this amount always tells you if this atom is reactive or not. If you have 8 valence electrons, it is not reactive. Another word for not reactive is stable. Another word you may also see is inert. If you have 1 or, please circle that, 1 or 7 valence electrons, these atoms are extremely reactive. If you have 2 through 6 valence electrons, it's just simply reactive. They will react, but not as extreme as 1 or 7. So 2 through 6 is reactive. 1 or 7 is extremely reactive because the goal is 8. 8 valence electrons are not reactive at all. They're stable or inert. And this is the goal for everyone. Everyone wants to be stable, which is why 1 or 7 are extremely reactive because they either need 1 more or 7 more. And we'll get more into that when we talk about periodic table, but this is what you need to know now. Valence electrons, 8, not reactive at all. 1 or 7, extremely reactive. 2 through 6 are simply reactive. So we're going to separate our paper into 4 sections because we're going to do 4 different elements today. The first one we're going to do is carbon, which is located on your periodic table. And it should look like this, or very similar to this. When we talked about our different squares on the periodic table, I told you that there were several pieces of information that you needed to focus on. We know that this element is carbon. This number here is our atomic number. So carbon's atomic number is 6. Its symbol is a capital C. And then we have atomic mass of 12.011. All right, so now that we know we have all of this information, we're going to use APEMAN, A-P-E-M-A-N. Remember that A stands for atomic number, P stands for protons, and E stands for electrons. Okay, all three of these, when we're talking about neutral atoms, are equal. So A equals P equals E. They are all going to be the same number. Okay, your mass goes on the other side. Atomic number is repeated again here. And neutrons is here. Your mass minus the atomic number will give you the number of neutrons. So mass minus atomic number equals neutrons. If we take a good look at carbon, we have the atomic number here and we have the mass here. We're going to do APEMAN, A-P-E-M-A-N. We're looking for our atomic number first. If you look at carbon, the atomic number is 6. So A equals 6, which means that protons also equal 6 and electrons also equal 6. Now we're looking for our mass. If we look at our mass here, it's 12.011. So with that being said, if this were money, this would be closer to $12 than $13. So we're just going to round it down to 12. So our mass is 12. We're going to look back at our atomic number, which is 6. And remember, mass minus atomic number equals your neutrons. 12 minus 6 equals 6. So now we know how many protons we have, we know how many electrons we have, and we know how many neutrons we have. We have 6 protons, 6 electrons, and 6 neutrons. Now we're going to draw our model. We know that protons and neutrons both are located in the core or the middle, which is called the nucleus. We know that protons are positive, so we're going to use a plus sign. We know that neutrons are neutral, so we're going to use this circle or this 0 here to represent no charge. And we know our electrons are negative. With that being said, our protons and neutrons go inside of the middle, which is called the nucleus. I know I have 6 protons, so I'm going to draw 6 plus signs. 1, 2, 3, 4, 5, 6. I know I have 6 neutrons, so I'm going to draw 6 zeros. 1, 2, 3, 4, 5, 6. And my nucleus is done. Now we have to place our electrons. So we're going to draw our first energy level or ring or orbital or shell. We know that only 2 electrons can fit on the first ring, but we have 6. So we're going to draw our first 2 on the first ring. 1 negative and another negative. So now we use 2. We still have 4 electrons left. We don't have room on our first ring, so we have to draw a second ring. Our second ring can hold 8, which is plenty of room for 4 more electrons. So we have 1, 2, 3, 4, which gives us a total of 6 electrons. 1, 2, 3, 4, 5, 6. Now, if we look at the last ring that we drew, we have 4 on the outside ring, which means these are our special electrons called valence electrons. We have 4 valence electrons. 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 4 valence electrons which means that carbon is somewhat reactive because it has 4 valence electrons. So that is our model for carbon. We did 8-man, we did a model. Now we're gonna move on to one that's a little bit more challenging. This is silicon. Okay, now moving on to silicon, we see the name here, we have our atomic number, we have a symbol. Now this time it's 2 letters, but you know it's still one symbol because you have a capital letter and a lowercase letter. And then we have our mass. So let's look at it here. We're gonna do 8-man, so A-P-E-M-A-N. We know that A stands for atomic number. Our atomic number is 14. We know that A equals P equals E, which means atomic number equals protons equals electrons. So we also have 14 protons and 14 electrons. Looking at our mass, we have 28.086. If we cover this last number, that's $28.08, which is closer to $28 than $29. So our mass is 28. Our atomic number again is 14. 28 minus 14 equals 14. So now we know we have 14 protons, 14 neutrons, and 14 electrons. And now we can draw our model. Again, we start with the nucleus, which is the middle of our atom. We know we have 14 protons, which are positive. We have 14 neutrons, which are neutral. So I'm going to draw 14 plus signs, or you can just put the letter P with the 14 because we know it's 14 protons and we know it's 14 neutrons. Now we know we have to place our electrons. So we have to do our first ring, which can only hold 2. So 2 electrons. We no longer have room on this first ring, so we have to draw another ring. Our second ring can only hold 8. We've already used 2 electrons, so we still have 12 more. We're gonna draw 8 because this is the maximum to go on the second ring. So 1, 2, 3, 4, 5, 6, 7, 8. And now we have used 10 electrons, but we've run out of room on our second ring. So now we have to draw a third ring. We still have 4 electrons left. So 1, 2, 3, 4. Because this is the last ring that we drew, we can see the last electrons that we drew, which are on the outside ring. These are special. They are called valence electrons. And we have 1, 2, 3, 4 of them, which makes silicon reactive. You will now do 2 of these on your own. The first one you're going to do is boron, B-O-R-O-N. And the other one you're going to do is beryllium, B-E-R-Y-L-I-U-M, beryllium. On your own, if you have any questions, you can leave me a comment below or send me a message. Remember, your periodic table is located in your folder for the week.